Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concept of optimization. So as per the problem, a fence is 1.5 meter high and is 1 meter from a wall. A ladder must start from the ground, touch the top of the fence and rest somewhere on the wall. Calculate the minimum length of the ladder. So the first step is to draw a diagram for this problem to understand what's given and what we need to find. So let's assume this is the ground level. Let's assume this is the fence and this is the wall and this is the ladder. So as you can see in this diagram, the ladder is touching top of the fence. So let's start by labeling this diagram. So this is the wall, that's the fence, and that's the ladder. As per the problem, the fence is 1.5 meter high and the distance between the fence and the wall is 1 meter. Now let's assume the ladder makes an angle theta with the ground. If we draw a horizontal line from the top of the fence to the wall, this angle here is also equal to theta. The ground line and this horizontal line between the fence and the wall are parallel to each other because both lines are horizontal. So as a result, the two angles theta are equal to each other because they are corresponding angles. This is a very important concept we need to understand and memorize. Now we can label the key points in this diagram. The line segment BD is equal to 1 meter long and triangle ABF and BCD are right angle triangles. We can assume that the wall and the fence are perpendicular to the ground. Let's assume the distance from A to B is X and the distance from B to C is Y. So the length of this ladder is X plus Y. So we can write an equation. In this equation, the length depends on two variables x and y. We should find the expression for x and y in terms of theta so that we have this length equation based on just one variable. And for that, we'll have to analyze triangles ABF and BCD. So let's start with triangle ABF. This is a right angle triangle, and in this triangle we know the side length opposite to angle theta, that's the opposite side, and x is the hypotenuse. So we can use sine ratio. The formula for sine is opposite over hypotenuse. We can isolate x by cross multiplying to the left side. Now we can divide both sides by sine theta. I get x equals 1.5 over sine theta. Now we can do the analysis for triangle BCD. BD is the adjacent side for angle theta and y is the hypotenuse in the triangle. So we should use cos ratio. The formula for cos is adjacent over hypotenuse. Now we can isolate y by cross multiplying y to the left side. Now we can divide both sides by cos theta. Next, we can do the substitution for x and y in the length equation. So this is the equation for the length of the ladder in terms of variable theta. Next, we should find the domain for this equation. Theta here represents the angle between the ladder and the ground. Theta has to be greater than 0. Theta cannot be equal to 0 because if we sub in theta as 0 in this length equation, in the denominator sine 0 will be equal to 0 and that will make the length undefined. So theta has to be greater than 0. And theta cannot be equal to pi over 2 or greater than pi over 2 because if theta is greater than pi over 2 then the ladder will topple over to the other side, and if theta is equal to pi over 2, the fraction 1 over cos theta will become undefined because cos of pi over 2 is equal to 0. So this is the domain for this length equation. Next, we should find the derivative of this length equation and set the derivative equal to 0 to find the critical points at which the tangent is horizontal to this length function. We have to find the minimum length of the ladder and the tangent will be horizontal at minimum points. Before we find the derivative, we should change this equation to make it easy to find the derivative. We should move the sine and the cos terms to the numerator, and that will make their exponent negative. Now we can find the derivative using the chain rule. In the first term, 1.5 is the coefficient of the term, so it will stay as it is. Now we have to use chain rule because this term has an inner function sine theta and the outer function is the power function with the exponent -1. So we'll start with the derivative of the outer function, and for that we'll use power rule. As per the power rule, we'll move the exponent to the front and subtract 1 from the exponent times the derivative of the inner function. The inner function is sine theta and the derivative of sine theta is cos theta. Now we can use chain rule for the second term. So we'll start with the derivative of the outer function, and for that we'll use the power rule. So we'll move the exponent -1 to the front and subtract 1 from the exponent times the derivative of the inner function, and the derivative of cos theta is minus sine theta. So this is the expression for the derivative of the length equation. Now we can set the derivative equal to 0 and simplify this expression. 1.5 times -1 is -1.5. The exponent of sine theta is -2 times cos theta, and in the other part, -1 times negative sine theta will be positive sine theta. In the next step, we should move the sine theta and cos theta to the denominator to make their exponents positive. Now sine theta square can also be written as sine square theta. Similarly, cos theta square can also be written as cos square theta. Next, we can move the fraction negative 1.5 cos theta over sine square theta to the left side, and that will make this fraction positive. So we get next we can cross multiply the denominators. Cos theta times cos square theta is cos cube theta, and similarly sine theta times sine square theta is equal to sine cube theta. Now we can combine the sine and the cos ratios by dividing both sides by cos cube theta. Sine over cos is equal to tan. Next, we should apply cube root to both sides. On the left side, the cube root and the cube cancel each other out. Get tan theta equals 1.1447. Next, we can find the value of theta by doing the inverse of tan. Zero 0.853 radians. And this value lies in the domain, so that means it's a valid value. Now we can check whether the length of the ladder is minimum at this theta value we got by using the first derivative test, and for that we can use the number line method. So we have to use a test value on the left side and the right side of this theta equals 0.853. We can use the test value 0.8 on the left side, and we can use the test value 0.9 on its right side. And we should sub in these test values in the derivative expression and check whether the function is decreasing or increasing on the left and the right side of this value we got. So let's start with the test on the left side. So first we should write the expression for the derivative of the length function, and the expression we got is now we can sub in theta as 0.8. Now we can evaluate this expression. I got negative 2.03082 for the first term and 1.4779 for the second term, and if we combine these two numbers we get a negative value. That means the slope of the tangent is negative on the left side of 0.853. That means the function is decreasing on the left side. Now we can do the test on the right side. So we'll sub in theta as 0.9. Now we can evaluate this expression. For the first fraction, I got negative 1.5196. Now we can evaluate the second fraction. I got 2.027. And if we combine these two numbers, we get a positive result. That means the slope of the tangent is positive on the right side of the theta value, 0.853 radians. That means the function is increasing on the right side. There is a minimum point on the length function at theta equals 0.853 radians. Now we have to find the minimum length of the ladder, so we should sub in theta is 0.853 in the length equation. Now we can evaluate this expression. I got 3.51 and the unit is meters. So this should be the final answer for this problem. So this is the minimum length of the ladder required for this situation. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.